our first class of good morning. So, welcome to the Edexcel IGCSE grade 10, the class where we talk about the grade 10 modules. Okay, so now we talked about, so during the last week lecture, we went through all the specifications, right? We talked about what type of papers you are going to get, the paper structure, and the module structure, and we briefly went through all the modules and the structures and the modules and the details about what we are going to learn, how we are going to do this, and so on and so forth, right? So if you missed that lesson, just go through the video. You can find it in the LMS, and also that is available online on my YouTube channel. So just search me as Vipula ICT or Vipula Edexcel on YouTube, and you can find my channel. And remember to go through that lesson. Okay. So now, since this is the second year, we are jumping directly into the unit 4. So we'll be starting from unit 4 itself, and then we'll be continuing to the next consecutive modules, and we'll be trying to finish off this particular set of modules by the time you guys get into your exams. So at the same time, now since we are starting from unit 4, I know there can be some students who has not still complete some of the lessons in the beginning classes. So for them, what I suggest is join our revision class, because the revision class will be conducted as a speed run. So we are going to go through the entire set of modules within this coming 5-6 months, just to make sure that we do all the short notes and we focus on the exam paper at the end, right? So here the reason I'm starting with unit 4 is unit 4 and 5 and 6 all mostly based on theory, and we talk about input, processors, outputs, networks, and so on and so forth. So without taking much time, let's jump in and see what is waiting for us in the unit 4. Okay, so now basic stuff. So last week during my session, again, if you missed that video, just go through my YouTube channel and find it, or you can find the link in the description under the LMS. Okay, so now since we are following the official workbook of computer science, this is the workbook first page. So this is a module explanation page. Now you guys should know, now these are the topics, like the specific topics which the curriculum expects you to know by now, right? So you should have covered these modules, the logic, hardware, software, and programming languages by the time we arrive at this particular unit, so that, because all these information which we are going to talk about today is mainly foundational or based on these topics which we have discussed before. Okay, so let's jump in and see. Now first page, we are getting into the unit 4 computers. Now what is the assessment objective, or what are the assessment objectives? Okay, now you can see here we have a certain set of objectives. Number 1, demonstrate knowledge and understanding of the understanding the key principles of computer science. Okay, so what is computer science? You should understand that, and why we need it, and the key principles of what it is. Okay, then objective 2, apply knowledge and understanding of key concepts and principles of computer science. So first one is demonstration, second one is applying, and the third one is analyzing problems. Okay, so here we have to analyze, we get the option to analyze problems, and here, so you can see in this case here we get to analyze problems in computational terms. Okay, what is computational terms? අපි මොකක් හරි කම්පියුටර් එකක් පරිගණකයක් පිළිබඳව කියන term එකක් නමක්. Okay, so there are a certain set of computational terms, and based on these, to make reasoned judgments and to design, program and test, evaluate and refine solutions. Okay, so these are the points which we will be assessed, or you will be assessed when you go to the exam based on this particular module. Okay, so now let's read let's read the basics part. So this unit introduces the hardware and software that together make up many different types of computer systems. Okay, so from embedded microprocessors to distributed cloud-based systems. Okay, so we will be covering up the major points about how a processor works, the role of an internal memory, secondary storage devices, and we will study about the logic that the computer uses when processing instructions. Don't get sad, logic, you are a logic kunata me. This is kind of like something interesting logic, right? We'll be talking about how a computer processes something. So I know for the past few years you have already learned about this topic on multiple times on how computer processes stuff and what is logic and so on and so forth. But then again, let's see how it works, right? So we really jump in, and in this case we understand the flows and the processes. Okay, so the first part we talk about point number 16, machine and computational models. Okay, so machine and computational models. So in this section we'll be looking at how the data is entered into a computer system, okay, and processed, and the results are output for the user. So again, question, what is data? So first of all we have to understand what is data, right? So when we say, or when we define something as data, there are certain set of aspects which we specifically need to have. So what is data and information? One question එක. So මොකක්ද data කියන්නේ? මොකක්ද information කියන්නේ? Good. Okay. So there are a couple of differences between these, right? So now data and information. So primarily data is a set of facts and figures, right? Data is just a set of facts and figures. So what is this facts and figures? And why do we need to enter data into a computer? Now, example is, let's do it. Let's think of a simple example. So you can write this down if you want as well. So please do take notes, but I will ask you to write specific stuff, but most of the time I will be explaining how it works, okay? So yeah, so now when it comes to the data, put a small asterisk sign and actually write this down. So data, what is data? Data is a raw set of facts and figures which is unprocessed, okay? And information, write this down as well. So information is data that has been processed and which has been given a context and a meaning, okay? So information is data which has been processed and that has been given a context and a meaning, okay? I hope it's clear. Okay, so if you miss miss that part, you can actually pause the video and you can write that down. Okay, perfect. So now we know what is data and information. Now this whole computational model, the idea behind having a computational model is trying to convert data into information, right? So let's think about this. Now, how does this work? So primarily, let's take now. I know, or most of you know what is Instagram is. IG, you call it IG, we call it Instagram, or the gram, anything. Okay. So now I'll tell you this in a very simple manner. So now you take a photo. So you go to a place and you take a picture, right? So let's say you go to a beach. I don't know, some place in Sri Lanka, and you take a selfie and you upload it into the platform, right? Into the social media platform, Instagram. Now what happens? Now, if you upload it just as a picture, what you're going to get is technically some data, right? What you have is some data. You just took a picture and you upload it into Instagram, and that's some data, right? So how do you convert this data into information? So what do you do when you are posting an image on Instagram or any other platform? Okay, so primarily what you would do is, after you upload the photo or the picture or a video, a short, a reel, I don't know, any sort of a content, okay, so you would actually put a title to that, right? So sometimes you will put a title, sometimes you will add a hashtag and try to tag someone, or there can be instances where you would actually tag a location. Let's say, okay, so you go to Port City and you take a picture. What would you do? So you will obviously tag the location as Port City, okay? Or you go to Kandy and you go to the Sri Dalada Maligaon and you take a picture there. What would you do? You would basically tag it as Dalada Maligaon. Or let's say you go to Gaul Beach, what not. Wherever the place, you would tag the place first. And if you visit a hotel, let's say you go to a nice hotel down south, then obviously you would tag the hotel as the location, right? And then if there's anyone in that picture, let's say you're with your family, then if they are also using the platform, you would tag them as well, right? So then now see the process. Now what you're currently doing is actually processing that data, right? So you got a small data point, as we call it, the photo. You took the photo, or photo ek gatta aragena. Now you're adding more information, or you're processing more data. Sorry, adding more data, or the facts and figures, the location. What were you doing? Feeling awesome, right? So people do this as they go to a beach and say feeling awesome at Unawatuna. So those type of so you add more information, more facts and figures to it, then that becomes information. Okay. Now I hope you guys got that point. Now next, this, why do we need this? Why do we need to convert data into information? So let's take the same example and think about it. So let's say if you just upload a picture, okay, you go to down south, you go to a beach and you upload this picture, and you don't add anything, just only the picture is there. Okay, so what happens? Let's say I'm a friend of yours, right? Okay, so I see this picture on Instagram. I would be wondering, who is this? I know who is this because we are friends. But then again, I would be wondering, where is he or where is she, and what is she doing, and is she has she gone there for a vacation, or office work, or with the family, or with their BFF or anyone, right? So we'll be like completely lost because that's just some information. But once you add all the facts and figures, let's say you add a text saying family vacation down south, Unawatuna, having awesome time with the pictures and with some food and the beach, then you complete that information. Now when I see that photo or that post, then I would immediately get the impression, she has gone on a trip with her family and the friends, and she's having a good time. So that is information. Okay. Now, what happened? So you processed that data, right? So you're the one who processed it. Okay. So a computer, on the other hand, what we use the computer for is to mainly enter some data and get that processed in a way so that it will basically help you in your day-to-day life. Okay, so why we need this is, so if you go back to the origins of computers, why computers were invented, it was all primarily because of complexity, because there's a certain limit the human brain can handle, and even if it is some simple mathematical calculations, I'm pretty sure you guys might be still counting. There can be some students who will still count using their fingers. I do still count using using my fingers sometimes. That's the way we use it, like just like this. Okay, so now when you get a big, like a complex calculation, then obviously if I get a complex calculation, I usually write it down, or if I have a calculator or my phone with me, then obviously I'm just going to type it in my phone and process that calculation, right? So that is also an input and a process. Okay, and we get the information processed and we get it displayed on the calculator, whatever the display in the calculator, and we can get that information. So this whole thing is known as the input, process and output model. Okay, now let's jump into an example now. Okay, so take out your books and I want you to write this. Okay, so here you can see few items. So you can see a car, you can see a printer, you can see a automatic washing machine, and this is a front loading washing machine with a fully automatic interface. What is this? It's obviously a remote, and this is a desktop computer, and here you have an organ, an electric organ, and here you have a phone, a smartphone. Okay, so now can we write this down? So the car. Now here the question is, how many computers do you have in your house? Or what do you think about these items? So how many of these devices you think that are computers? So write this down, write 2 columns. In one column, put the device name. So in this case, this is a car, right? So car, printer, remote, PC or personal computer or desktop computer, and organ and smartphone or mobile phone, or you can write it as iPhone or Android. Whatever the easy term for you, and a fully automatic washing machine. Okay. Now in the first column, write this down, and now write another column. Okay. In here, in this particular column, write down the type of computer this is. Okay. I want you to understand what type of a computer this is. Okay. So let's start with the less complicated stuff, right? So let's take the computer itself, a desktop computer, this one, right? So this guy. Now this guy, yes, obviously it's a computer, right? So it has as we know, it has a central processing unit, a CPU, where it allows you to process data, right? Simple as that. We all know that how it works. So then the car. What type of a computer is a car? Or what do you have? So inside a car, what type of a processing device do we have? Think about it a little bit. So so since you have written down in the first column as car, so in the second column, let's write down. So how many devices? So this is research. Huh? This is how we look at this is the analytical view of the world, or how you look at the world in a mindset which is related to computational thinking. So what type of computers they are there and how it works. So simple. Get back to this one. So cars. මොනවද cars වල තියෙන computers? මොනවගේ දෙයක්ද තියෙන්නේ? අපි okay, so let's don't take into don't think about the latest models. I mean the latest cars and all, they are like totally out. Okay, sorry, my bad. It's the other way around. Let's not think about the old cars. Okay, so old cars are totally out. Old in the sense, if it is something which came before 1990, then there's a little bit of a chance of having a computational device in it. But yes, there are some microcontrollers. That's something different. But let's think about new cars. Let's say a Tesla. That's a complete computer, right? You have braking systems. Okay, so write this down. So for a car, we have brake systems, automatic braking. Now with the new cars, we have auto drive or autopilot. We have multimedia systems, right? And cruise control systems to make sure that your car is controlled properly, right? And safety systems, right? And let's say the last one, we'll call it as engine control systems, or ECUs, electronic fuel injection systems, and so on and so forth. Okay, so just write those things down so that you know what it has, right? So inputs and outputs, obviously, when you get into the car, you press the pedal, you press the gas, and when the gas is pressed, most of the new cars, even in my Jeep also, it actually works in a different way, where your accelerator does not actually work in a mechanical way. So that's a digital accelerator. So when you press down, it digitally increases the speed. So there's a computer, and that computer controls the accelerator power and the pressure, right? Okay, then a printer. So that's about a car. So about a printer. So a printer is something which is quite straightforward. Also, is this a computer? Yes, yeah. So this also does some internal processing, right? So what does it do? It primarily, what it does is it basically gets an input from a computer, right? Okay. So once the input is received from the computer, it will convert that input into an action, an activity, right? Because the printer, as I hope you guys know, how it works is it moves a printer cartridge, right? And in that cartridge, you have the ink, and that ink is getting sprayed on top of a paper, right? So when that happens, that conversion, so the computer should send the signal to the printer, and the printer recognizes it, and it converts into movement with the ink sprayed on the paper, where it will end up by creating a print of that particular document. Okay, super. So that's the flow of that. So please pause the video and write this down, because you get questions asking what type of inputs and outputs these devices have. Okay, then our good old washing machine. Okay, so this guy, this is also technically a computer, because it does lot of different activities. Because okay, example, you can see here, so this is known as a front loading washing machine, right? So here you can, on the top you can see we have the console, which will be basically the buttons and the configurations, and here, over here, either these 2 points, right, you have this loader, where you basically load soap and everything into the washing machine itself, right? And then what happens is, when you put the clothes in and you program, you select what action you need, and then it processes those actions and it washes your clothes, right? Okay, so write this down. So what are the inputs you provide, and what is getting output? So here the input is, you select input. Number 1 is select the type of wash, or the type of type of washing you need. So that is one input, and you put the clothes in, right? And then this recognizes this whole structure and whole set of instructions, and at the same time you put some detergent and washing powder as well, right? That is also kind of like an input. And what happens is, based on this input, it takes in all the factors. Now example, if you haven't put any detergent, then obviously the washing machine will send you a message and say, sorry, no detergent found. Right? So you'll have to put more detergent in, or put detergent in, and then you will have to start the washing process, right? Okay, so now that is how it works. Now I hope you guys are writing this down. So please take the notes in and take it down. So super. Then we'll talk about this small guy. Obviously, you guys know what this is from your younger days. Like since you were a baby, you should have seen one of these. So what is this? It's a remote. So simple. What are the activities a remote does? It takes in an input. What's the input? A press of a button, right? So input. So write it in the second column. You press a button, and then this guy has a fixed set of instructions. Okay, I will show you guys some interesting stuff when we jump into the networking, because I do have some tools which we can play around and see how these remotes work, how these signals work and all. So I just told you that since I remembered it, but let's see. Okay, so back to the action. So you press the button, you have a fixed instruction in it, and the remote has a computational or computing device or a microcontroller which will understand that, and that data is being sent out, right? Simple as that. So if I show you guys an example with this remote. So I do have an AC remote here. So in this AC remote, you can see the temperature is set to 24. Now if I click on the increase button, what will happen is, increase or decrease button, you can see that the temperature goes up, right? So here what happens mainly is, this particular button is actually set to increase or decrease the temperature, right? So you should be able to hear the AC sound. See that small beep which you can hear is basically increasing the sound. So what happens is, when you press the button, there's a there's a sensor. So you have the IR blaster in top. So what it does is it processes the details and it sends the message out. So that's how this guy, that's the computational part. Okay, so the computer, anyway, you know, the computer is anyway there to read and track stuff, right? Okay, and then what about this guy? Now, for the computer, you guys write down, nah? So write down all the inputs and outputs you can get from a computer. So you already know this. You will type a key on the keyboard, or you can move the mouse and the cursor will be moved, and so on and so forth. So write it down and show it to me later on. Then we can check your answers. So this guy, the keyboard. So what type of a computer is this? This is a computer, yes. And what it does is it produces sound, right? So you have a set of keys. So starting from here until here, you have a set of keys, right? So when you press on one of these keys, what happens is that will complete a circuit, right? So there's a key and there's a small circuit. When you press on it, the circuit gets completed, and what happens? Immediately some event, right? Some event gets fired. So when you click on it, the circuit gets completed and an event gets fired, which in return, inside the microcontroller or inside the system, we have defined a set of actions to happen, right? So when you click on this, these actions will happen, and then automatically a sound will be produced, right? So okay, let's write down the actions. So you press a key so this is the keyboard or the electric organ. When you press a key, so input is a key press. The process is there is a designated sound programmed to each and every key. A designated sound is programmed to each and every key. Okay, then the output is, as you know, it's sound. So you input, you press the key, the processing is the processing of the designated output for that particular key, and the output would be sound, right? Simple as that. Okay, perfect. Let's quickly jump to the next one. So our good old smartphone on the bottom. Okay, so this guy, we have a lot of inputs and outputs. So I want you to write that down. So you all know what we can do with a smartphone, right? You can send as an input you have touch, you have voice, and then output you have a lot of stuff. You can take pictures and it processes and it gives you a completed picture. Likewise, I know you guys can come up with a lot of answers for this. Okay, so write this down, and I need to show me your work later on so that we can see what you have written down. Okay, so if you need some time, please pause the video and go through what I just explained, write down the points, and make sure you understood all the inputs and outputs. Okay, so jumping to this part. Okay, so again, I discussed this last week about the general vocabulary, or these small blocks where you can see on all the pages. Okay, so now here this is a general vocabulary block. Okay, so what does it say is sorry, hold on. Yeah, why can't I zoom in? Is it okay? Hold on. Yeah, anyway, I hope that's readable. Okay, so here's a vocabulary point, so a key point. So here what it says is embedded. So what is embedded? Embedded or fixed firmly into another object. Embedded is basically fixed firmly into another object format, the way in which something is arranged or set out. Okay, so embedded means, in simple terms, embedded computers means you get, okay, so I'll explain this in a very different simple way. So when it comes to embedded devices, what we call it as embedded is, to a main process we embed another device. So example is we take the car, right? So the car stereo, or the setup, or the radio of the car, it has an embedded computer. Okay, embedded means that computer is there in the system just to process a certain set of activities, right? So in the sense now, it's a different device which performs a different activity. අපි මෙහෙම හිතමු, when you press the brake, right? Brake එක ගහපු හැටි automatically, now these vehicles have this thing called ABS. So it's basically something similar to a anti-brake system where it will make sure that the car won't slid. Okay, so how it works is, when you press the brake, automatically there's a computer, so there's an embedded computer which will understand that you have pressed the brake, and it will understand the pressure and the speed of that particular pressing of the brake. Okay, so based on that speed and pressure, what it will do is, it will automatically start processing the data, and it will automatically slow down the car and control the braking so that your car won't skid. Okay, so other way around, if you go back to this AC example, when you AC remote example, so that remote has a set of input devices, right? You have the buttons, and it has an output where it will oh, sorry, 1 second. Yeah, so the remote has inputs where it will take in the button press, and what happens is, when you press the button, an IR blaster will be, so IR blast is basically this thing here, okay, this one, and it will basically send the signal out, right? So in order for this to process, we have a compute chip, like a microcontroller inside it, and that is known as an embedded computer. Okay, now don't get this word mixed up. Then for the normal person, අපි කිව්වම computer එකක් කියලා, what you expect is something big, huge, like a laptop or a big desktop PC, right? But no, that's not a there's nothing to do with that as a computer. Now, as you guys can see, I have this small microphone plugged in to myself. So this particular microphone, yeah, as you guys can see, I have this microphone. So this also has an embedded PC, embedded chip inside it, because that will automatically transmit my voice into a receiver which is connected to my PC right now, and that receiver is basically taking in the data and it is pushing it out into the video stream which you guys are currently watching. Okay, so that's how embedded computers work. Okay, so theory. Now I want you to write this down. So draw this diagram. So the input and the process and the output. Guys, when you're drawing this, please please be mindful about the structure. I mean the shapes. Okay, so this is always an input shape which will have this particular structure, and you have the process and you have the output. Okay, so please be mindful about how you draw this, and then from there we can go on forward. Okay, super. So please draw this, and then let's discuss about the point. Okay, so this is what we, yeah, so this is as we discussed with the point. So we have the input, and we have the process, and we have the output, right? So this is what we so far discussed. So obviously now since you have written down the inputs and outputs, let's just do this activity and see, just to think about this in a broader view. Okay, now name any inputs and outputs for the desktop computer and the washing machine. So we already wrote this down, right? I hope you wrote it down. If you haven't, go back to the video, go back to the point where we were discussing it, and please do write it down in the table. Okay, now second question, what is it? Alia is an air condition system installer. Researching the computing devices she might use. So our goal is to research the computing devices she might use in her job. Okay, so air conditioning systems. What is air conditioning systems? So hope many of you have air conditioners at home and or at school. Okay, so what type of computers do we have in an air conditioning system? Any suggestions? Okay, so start off with primary device, remote controls. All remote controls have computing devices, right? So every remote control has an embedded computer, which will technically process the data, and will try its best to push it out, right? So it takes the input and process, and checks the definition of what type of a data which has to be sent out, and it will be sent out to the air condition, right? Okay, so from the point of view of an air conditioner, what type of type of a controller does the air conditioner have? So that's something interesting. Okay, now I'm not sure I can show you guys this one, but let me try to show you something. Hold on. Sorry, no. I was trying to. Was actually trying to show you something. Let me try this in a different way. I want to. Hold on. Let's try if this works. So. No, no, sorry. Okay, so it's a bit hard to connect this screen with it, so I just try to sync if it is possible. Okay, so what I wanted to show you was there's an AC right uh, on top of my head. Okay, so in this AC there are two specific controllers. So controller number one is we have the thermostat or the thermal detection controller, right? What it does is it will basically detect the temperature inside the room, okay, and then it would check if that temperature is set to the same range as the temperature which we have defined in the remote or defined by the user. And if it is the correct temperature, then it will try to maintain it, but if it is not the correct temperature, then that is going to change. So it will automatically turn up or turn down the heat, and we'll try to manage the temperature. As well as how it works is there are different types of computers which will basically, sorry, AC controllers. Now, example, I had a good experience long time ago. Some time back I had a Panasonic air conditioner which has this motion detection part. So how it worked was it had a small motion detection sensor on the top of the AC, and when somebody enters the room, it detects that particular person's body temperature and automatically adjusts the AC to that person's area. So example is, let's say if I'm in the room and you also come into the room, then it will detect that you came in and it will check for your body temperature, and if your body temperature is high, then it will automatically direct the airflow towards you. Okay, so it was actually fun. So it had a computing device, an embedded computer to handle it, but the problem was something a bit different. So I do have that. Back then I had couple of dogs at home, and while I was working inside the office, these guys also wants to come in because obviously during the daytime I keep the AC on, and dogs, they love ACs. They love to come and sleep inside cool, like chilled or cool rooms. So what happens is this: when this guy comes in, the AC automatically detects the dog, and most of the time canine body temperatures are higher than us. So dogs have a high body temperature. So when he comes into the room, automatically the AC redirects all the air or the airflow towards the dog, and I start to sweat inside the room. Okay, so yes, so that is also being done by a embedded computer. So that's why. So that's an example for this one. Okay, now and then this part is a group discussion, so we can actually skip it. Okay, so now the point again. So again we have a subject vocabulary. Okay, so guys, I want you to write this down. So the subject vocabulary is, you have to write it down: input. So input, please do spice things up. Huh? Input means to enter data into the computer. So I would really love to see something like a person typing on a keyboard, just a small picture. So if you draw something like that, then obviously that's going to be stored in your mind. Okay, so okay, I'll explain the reason I'm asking you guys to write it. So the idea behind this is there are three different types of learners in the world. So we have one learner who will learn by looking at it. Okay, so there will be some students who will basically who won't have to write anything down, because you have the book with you, and since I'm explaining the book in very clear form, that would be enough for you. That's category number 1. Category number 2 is there are writers. So you need to write in order for you to memorize. So for them, what I suggest is you have to write. And so listen and write both. Okay. And then there are some learners you have to practice it as well. So by listening and writing and by practice only you will remember it. So for me, I'm coming from a background, so my learning ability is a bit different. So I am kind of into the third point. So I really want to practice. So if I practice something, I'm never going to forget it. So if I only look at something, yes, I will remember it for some time, but maximum about month or two, then I'm going to forget about it. If I listen and if I write it down, then when I read through what I have written down, then I will immediately remember it. But if I listen and write and practice just by drawing something, then that's going to be like hard coded in your mind, like as you just upload it into a hard disk and you just mention it there. That will be there in your mind forever. Okay, so please follow this pattern. So so take these notes down, and when you're writing it, just draw a small picture. So input is basically to enter data into the computer, and process is to change the meaning or the format of some data. And then output is to display or output data that has been processed or has been stored. Then we have this selected vocabulary called function machine. So function machine is actually just a metaphor or a diagram that represents a machine that takes an input and implies some sort of a rule on it, such as a set of operators or something, and which will deliver an output. So let's jump in and see what we have understood at this point. So write this down, then come with me to the next part. So in unit 1, when we talked about algorithms, we talked about some precise methods on solving different problems, right? So I hope if you remember the algorithms. Otherwise, jump into the revision class. We'll be going from the beginning again. Okay, so now here in this case we'll be solving. So we learned how to solve problems by step instructions, so that it would process in a sequential manner, right? So it will be processed in a sequential order, and it would be processed based on the input, process, and the output. Okay, now here what happens is, now here you can see what are we going to do. So we have the input. So here we are taking 3 in as the input. And what is this action? So in this case, this action is multiplying. Yes, we are multiplying it by 2, right? So now the input is this one, and we process it by multiplying it by 2. And what is this one? We add another 2, right? So we had 3 multiplied by 2. What is the answer? 6. And 6 plus 2, the output is 8. Okay, so that's how this entire process works. So you get 3 multiplied by, so this is the processing part. Okay, now here this is basically a algorithm where we created a small flow where when you enter 3, that's getting multiplied by 2 and incremented by 2, and you get the answer, right? So in technical terms, this is a functional machine, right? So here you will probably need to keep track of your whatever the working in a specific way, so that you would basically change the diagram or the structure according to your need. Okay, so let's jump in. And now this is about the point which you draw earlier. Okay, so I hope you guys do this one, right? Okay, now since we went through this, now you know what is processing is, right? So since this is the processing part, now you know there has to be another point behind this, right? So now what happens when you process something? When you're technically processing something, that data has to be stored, right? So example is when you get some data in and when you process it, that processed data has to be stored at a certain point, right? Otherwise, how are we going to use it later on, right? Okay, so let's go back to our IG example, Instagram example. So you upload a picture and you add the details to that picture, and then and then you save it, right? You save and you publish that picture to Facebook, Instagram, the platform, right? So Meta gets all your information, and Mr. Mark Zuckerberg gets to show some advertisements, and they will use your information to promote their platform, right? Okay, so that's a different story, but that's how it works. So now, in order for your picture to work and to display, you need this particular data stored, right? So that is where you get the storage part, right? So I know you guys have already done this lot of times about the data storage and the process. So let's fill this up and see what type of inputs and outputs you can write about your school subjects. Okay. See if you can find an example for each subject starting with the ones in the text like this. Okay. So subject art, input is paint or paints, and process is instructions, and the output would be an art or a watercolor. Right? So what else? Let's take something else. So let's what do you say? Let's take music. So music, what would be the subject would be music, and the input, what would be the input? So here the input is paint, and in music, what would be the input? Okay, let's make it simplified. So let's think about in a different way. So yeah, music. Let's take you do a specific instrument. Okay, so input would be the playing of the instrument. Let's say if it is an organ, you play the organ, and the process would be the organ will process your notes which you enter, and the output would be sound or the music. Okay, so think about the each row. For each row, think whether the rules or the instructions for the processing are similar and or different, and think about how you can find it connected to computer science. Okay, so I'm going to give this as an homework. So go through this and try to fill up this form and show it to me so that we can go through it and see how it works, how you have done it. Okay, perfect. So then so that's a brief introduction about input, process and output, right? Now we jump into a bit of a complex part where we talk about computational models. Okay, so what is a computational model? It's a it's a bit of a controversial, like a popular topic. Sorry, not a controversial topic, but a popular topic. Okay, so computational models, they basically describe how algorithms are executed by a machine. Okay, so by processing, so example is by processing data using inputs and simple inputs and outputs. Oh, there are different models how this processing can be carried out. Okay, so computational model means basically how some data set is being processed. Okay, so we have three different types of computational models which we talk about in your particular curriculum. Okay, so let's see what are these computational models are. So start off with, we do need to jump into the general vocabulary. Okay, again, please go through my first video where I explain these keywords and the way you can, where you have to write, sorry, where you will be required to write answers. Also guys, in the revision video that is also available in my YouTube channel, find that video. That also, in that video I explain how to answer a question and what's the process of answering three different types of questions in IGCSE. Okay, so I am really emphasizing in this point because when you're writing the answer for these questions, you need to make sure that you will always work on these vocabulary and these keywords. Okay, so these keywords are very important, and everything which you focus on is basically based on these keywords. Okay, so primarily computational, you have this vocabulary keyword called computational, which is connected to computers. Parallel is two parallel lines that are at an equal distance from each other. Okay, computational means connected to computers, and parallel means parallel means two lines. So it will be that just like two lines running parallel with each other, right? So in this case, we talk about two things getting executed at the same time. Okay, so I will show you guys a quick example on what this is, parallel computing and sequential computing, just to give you an idea what this is. Okay, so hold on.
I introduced to you Leonardo, and he's going to paint the picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up.
So what you guys can see here is, this is a simple example of sequential computing or sequential processing. Okay, so you can see this is this is
Formed sequentially, one after the other. In 3.
So listen to the word. It says this prints or this process sequentially one after the other. So that means one at a time. Tick, 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 tick. Okay. So see what is sequential.
2, 1. Let me speed it up. Ladies and gentlemen.
Okay, so you saw how it works, right? So the reason I want to show you this video is it's really easy for you to understand now. So sequential is taking time, right? It always process one in, process out. in, process out, in, process out. Right? Now let's see how parallel processing works.
Leonardo 2.0.
When we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes, in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
And 10,
9,
9,
8,
7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over.
Okay, so there you guys saw the video where how parallel processing works. So the core concept of this video is to show how a CPU and a GPU works. Okay, so the CPU is basically a processing device which process its data in a sequential manner. Okay, like as you guys saw here, in this case we have the robot. So this guy is basically pushing things, printing things one by one. So that is why we don't use CPUs for gaming. So when you want to game, just think, if you're gaming, or let's say if you're playing a car race or a racing game or a first person shooter game, so then FPS game, so then what happens, like if it goes frame by frame, like tick 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 tick, then it's not going to work out, right? So that's why we need parallel processing, so that we can get a GPU similar to the performance of a GPU. That's why we have GPUs, which will basically, without sending it one by one, it will literally send all the data points. So these are the data points, right? It will send you all the data points at once, which will make things go much faster. Okay, super. So let's jump back to our lesson. Okay, so parallel processing. Now, since we saw this demonstration on sequences and parallel, let's see what this is. So in the sequential model, this is the way we commonly imagine how computers work, right? That is how a typical computer works. So this involves following instructions and algorithms step by step in order from start to finish. The video you guys saw where that smiley was created, one at a time. Okay, and then in the parallel model, it works in a different way, where the computer processes are distributed between two or more processors. Now in example, in a VGA card, there's about 1,500 plus cores, in the sense like processing cores, which process all at a time. Okay, so that's why when the VGA card, when the VGA chip gets upgraded version, they say you get more graphics in this, right? The reason you get more graphics is because your version, that your CPU has more capacity to produce or process more data at a time, right? So that's how it gets the processing done. So now parallel, so the concept is, in the parallel model, which is distributed between two or more processors, which is installed. So each separate part of the algorithm, okay, is split into each process, and since it's getting processed at the same time, the software is extremely faster, as well as it will be basically giving you much more faster output or performance at the same time. So perfect. So why do we need parallel computing? So yes, gaming and processing and all these type of stuff, yes, that's obviously required. But apart from that, parallel computing. So we will learn this when we jump into the networking module, which is the next unit. But just for the moment, you guys need to understand now. We have servers, right? So servers basically allow us to host applications, web applications, and these web applications allow us to communicate with the server and perform some activities, right? Okay, so think of it like this. Let's take YouTube. So if YouTube has a specific type of a server where, let's say, if YouTube uses sequential processing, then what will happen? Technically, it's going to be a problem, right? Because YouTube will start processing things sequentially, and that's going to be a problem because only one user will be able to watch a video at a single time. So YouTube has millions and billions of people accessing YouTube every second, right? And trying to watch videos out of it and consume content basically. So for that, obviously, for the servers, we need to have parallel processing, right? So the server must have high-end performance because otherwise it's not going to let you access, right? You get the point. So that's technically how it works. So in those type of situations, parallel processing is a must. Okay. So on top of it, so I hope you guys got that basic idea. And then on top of all these things, we have the multi-agent model. So multi-agent model is very complicated, and it basically allows you to go forward with different processing agents at a time, at any given time. So how does it work? So in the general vocabulary, we'll just check this out. So we have the coordination, which is basically organizing different activities so they work together, okay, together effectively. And at the same time, we have this keyword called negotiation. So negotiation is basically discussion in order to reach an agreement. So what is this coordination and negotiation has to do with multi-agents? So let's check this out. So in multi-agent in the parallel model, as you guys know, one task is processed by several processors, right? As you saw in that video, in order to draw that image, it was being processed, it was being sent by multiple different AR cannons, multiple different processors, which basically drew that image, right? Other way around, in the multi-agent model, that goes in a little bit of a different way, where separate tasks and algorithms are processed by different systems. In this case, agents to perform a particular function. In this case, each agent acts as independently and under its own control. Okay. Now, I'll explain this in a bit of a different way when it comes to think of this as let's say if you go with the production line, okay. Now, when it comes to vehicle production line, so food production lines, we do have this concept called multi-agent architectures, okay. So how this works is, these multi-agent architectures, multi-agent systems, they have different devices connected with each other. Okay, so these devices, what they do is they perform separate actions. So let's say if a food item, okay, let's say we have a food manufacturing plant, let's say apples or potatoes. Okay, so at one side you feed the potatoes into a big conveyor belt, and that conveyor belt starts rolling, right? So that rolling part, that conveyor belt where the food is being sent through, that is going to be one agent, right? So in that computing agent, in that system, the goal for that agent is to make sure the potatoes are moving forward. Okay, now at the same time there's going to be another sensor on that particular conveyor belt just to scan for rotten potatoes or damaged potatoes, right? So there will be a camera on top of the conveyor belt, and that would basically scan the potatoes and find out if there's any rotten potatoes in the conveyor belt, right? If it finds any rotten potatoes, automatically an arm will push it away from the main moving conveyor belt, right? So if that's the case, then see how it works. Now for that particular processing, that's a different agent, right? So as a whole, the factory is a single process. So from one end you get potatoes, the potato is getting scanned, it's getting washed and it's getting cleaned up, and it's getting packed, right? So simple action. So input is potato, you get the raw potatoes, output is the packed and fully cleaned and washed and packed potatoes, right? Simple as that. But in between there are multiple different actions which has to happen. You have to wash it, you have to check for rotten potatoes, you have to check for damaged potatoes, you have to sort it according to the size, big ones into a different different basket, small ones into another basket, right? So all these points are actually split into multiple agents. So that is where we get the multi-agent concept. So each agent is autonomous, okay? So you can see here, so each agent is autonomous, okay? But they cooperate with each other through negotiation and coordination. Okay, so this is partially or almost about 90% based on AI, because now AI models are there to find things out and to make it easier. Okay, so this negotiation and coordination will automatically happen based on these agents. So now if you search for this on Google with multi-agent systems, you will be able to find a massive lot of things which you will basically understand how it works. Okay, so now we have a activity. So in this activity I want you to do something. So I want you to write a program. Okay, so I assume you guys all know Python, right? So so I want you to write a small Python program which will basically decide the mathematical steps required. Okay, so then ask your partner. Yeah, you don't have to ask for a partner, but you can write it. But you just need to make sure that you put some inputs in, and based on a specific algorithm you give a output. Okay, I know this is just a simple code. So let's say you write something like this. So ask the user for their password. If the password is 8 or more characters long and contain at least one uppercase letter and at least one symbol, then display the word strong. Otherwise, just display the word as weak. Okay, so I hope you guys know, you guys have done the string part. Otherwise, I will be actually covering that part in the IGCSE first class, as well as we'll be going through this during the revision classes as well. So please do work on this, and let's discuss about this next week if you have done it. So if you have done this code, please either send it to me on WhatsApp or show it to me so that we can actually find out how it works. Okay, so yeah, this is the algorithm, and okay, now we arrived at a checkpoint. Okay, now this checkpoint is an interesting thing, because we need to make sure that we learned this particular points. Okay, so now I want you to take your books out again, and I want you to write these questions, and I want you to write the answers for this particular thing. So I'm not going to give you the answer right now, but we'll discuss it during our next class. But first I want you guys to write this and then show it to me during our class next week. Okay, and then I will go through it with you, and we'll understand how you learn this. Okay, so checkpoint, what are the skills? So we have few skills: critical thinking, reasoning, critical thinking and reasoning, and the final one is problem solving. Okay, so when it comes to the strengthen part, what is meant by the term input process output model? Read and write the answer. Read the top part and write the answer. What are the inputs, outputs, and processing involved in uploading an image to a social networking profile? Okay, now here, this is, I started the lesson with this question. If you, explaining how this works. So if you missed it, go back to the beginning of the lesson and follow this up. So I explained how this thing exactly works. So I want you to write it down. Okay, now in your own words, what are the sequential, parallel, and multi-agent computational models? Now we learned what is sequential, we learned what is parallel, as well as we learned what is multi-agent. So sequential, you guys saw this video for sequential and parallel, and for multi-agent, I explained you the point where we have this conveyor belt and this potato factory, where you have different agents to perform different activities. So I want you to write this in your own point of view, and we'll make this an homework. So during the next class, I want to go through this and discuss the questions with you. And the final one is basically to create a computer program, but we can leave this as it is for the moment, challenge. But I want these 3 questions answered by the time you come to the class next week. You get exam questions. So these are like very common exam questions for this particular module. So be careful, pay some attention, and make sure that you write the answer. Okay, then we have a summary. So summary of all the key points. So now, as we discussed, all the computers comes in multiple different shapes and sizes, but they mainly perform the same thing at the end of the day. Right? They all take an input and process and output based on a given set of rules, right? And then there are different models that different complexity for the processing of the data by the computer systems. So basically algorithms are exposed in computer code so that it will basically carry out computer tasks. Okay, So, perfect. So, we are jumping into the module hardware, but so please do work on the details, the questions I mentioned here, and watch the video again if there's any questions. And also, if you have any questions, please feel free to send me a message on WhatsApp and ping me, and we can have a longer discussion, and I can answer your questions. Okay, so until then, let's wrap up the class for today, and let's meet up next week to start off with the hardware module. So at the same time, remember to join the revision class where we'll be doing a speed run starting from the module 1 until the end. So the revision class will be, the goal will be to finish up all the theory parts by the beginning or end of April. So we do have 2 months to complete our studies and papers and do well in the paper. Okay, exams. So until then, catch you back next week. See you.